Okay, let's do some more examples with unit conversion. Let's say we want to go from 20 centimeters to a meter. What I'd like for you guys to do is, actually, let's do this. Let's have you pause the video, try to do the first problem, and then unpause it. We'll go over it, and we'll kind of complete that pattern. So try that first problem real quick. Pause the video. Okay, so if we want to go from 20 centimeters to a meter, let's think about that chart. So I'm going to put that chart over here. So we're going from a centimeter to a meter. We're going from a small unit to the base unit, which isn't shown here, but that would just be times 10 to the 0. So centimeter, meter. So small unit to a larger unit. So we're going to move to the left. And let's set up our number line. So we're going from times 10 to the negative second, negative 1, 0, and we want to go to meter. That's times 10 to the 0, because 10 to the 0 equals 1, meaning we're not changing the unit at all. So we're going to move 2 places. So if we're moving 2 places to the left, and there we go, we get 0.2 meters. Let's try this second one. So you guys pause the video, try that one out. Okay, so we're going from amps to milliamps. So amps is the base unit. That's going to be up here. And then we're going to milli. So we're going to move to the right. We're going to a smaller unit. So we're going to move to the right. Let's set up our number line. We're going from amps, so that's going to be 0, to milli, so that's negative 1, negative 2, negative 3. And we know we're going to move to the right 1, 2, 3 places. So we'll set this 1, 2, 3. So it looks like our new unit is 32 milliamps. Okay, we'll try the next one. You guys pause the video. Try the next one out. Okay, so we're going to go from micro to nano. So here's micro, nano. Now, just because they're next to each other doesn't mean we're moving 1 decimal place. Look at, they're 3 apart from each other. So we're going from micro to nano. So we're moving to a smaller unit. We're going to move to the right. We'll set up our number line. So we've got negative 6, negative 7, negative 8, negative 9. To get all the way there, we're moving to the right 1, 2, 3 places. So when we move that, we'll go 1, 2, 3. Now it looks like that's going to be 45,000 nanometers. There we go. All right, we'll try the last one. Pause it real quick. And we'll do this one together. So we're going from decimeters to kilometers. So deci is here, kilometers up here. We're going to a larger unit, so we're going to move to the left. And deci is negative 1 and kilometers 3. So we're going to go negative 1, 0, 1, 2, 3, and that's going to be 1, 2, 3, 4 to the left. So we're going to go 1, 2, 3, 4 to the left. And we get 0.0805 kilometers. All right, let's move on. So we talked about volume when we were talking about density the other day, but just to review, volume is the amount of space occupied by an object. Some objects, like rectangular prisms and spheres and things, are easy to calculate the volume of. The example here would be if we have a brick of a certain size, Let's say we have a brick. Let's say that this brick is 5 centimeters by 15 centimeters by 5 centimeters. So we could find the volume by doing the volume equals the length times the width times the height, which in this case is going to be 5 centimeters times 15 centimeters times 5 centimeters. We're going to get 375. Now the units are not centimeters, right? We've got 3 centimeters here, so this is going to be centimeters cubed. That's important to keep in mind because it's a volume, it's not a length. So there we go, centimeters cubed. If we're measuring a liquid instead, if we've got a container with a certain amount of volume in it and we're measuring a certain amount of liquid, we're usually measuring in liters or milliliters, which we abbreviate as L or ml. Okay. Now, mass is different than volume. Mass is a measure of the quantity of matter that an object has, the amount of stuff it's made of. Volume is how much space that stuff takes up. So it's different. A bowling ball has a mass of about 3,000 grams. Remember, the SI unit for mass is not a gram, it's a kilogram. So if we were to convert, a bowling ball is about 5 kilograms. Now a golf ball doesn't have nearly as much mass. It's about 1/100th the mass of a bowling ball. So a bowling ball is 100 times greater in mass than a golf ball. And a ping pong ball or a tennis table ball is about 1/2000th of the mass of a bowling ball. So just to give you kind of an idea of how much mass everything's got. Remember that density is calculated by mass divided by volume. And so we get what's called a derived unit. It's a unit that's a combination of other units. We get grams over centimeters cubed. And here's some densities of common objects. So you can see obviously hydrogen is way less dense than iron. And let's go back and do some more practice problems with density. So again, a derived unit is a combination of other base units, and density is an example of that. Density is a mass divided by a volume. So we have a mass unit divided by a volume unit. So density has what's called a derived unit. Okay. So we'll do the same thing we did before. I'm going to give you guys a little bit of time to try the problem. You're going to pause the video, then you'll unpause it and check your work with the solution. So it says an object has a volume of 875 cubic centimeters and a density of 13.6 grams per cubic centimeter. We want to find the mass. We'll do this 2 different ways. So one way is we could say, remember, density is mass divided by volume. We need to find the mass, so we're going to multiply both sides by volume, and we'll end up getting volume times density equals mass. Now remember, we could have also done this triangle method by blocking off the mass, which is what we wanted, and seeing that these are next to each other, so we need to multiply them by each other. So we're going to multiply, and we're going to get mass equals 825 cubic centimeters times 13.6 grams per centimeter cubed. And these will cancel out. These two units cancel. We're left with just grams, which is what we want, a unit of mass. We'll multiply those. And there we go. So that's our number of grams. So let's see how we did. Nice. Now if we wanted, we could convert this to kilograms, and that would be 11.22 kilograms. All right. Next one. So here we have a liquid has a density of 0.87 grams per millimeter. What is the volume occupied by 25 grams of the liquid? So we can set this up. Density equals mass over volume. We want to know the volume, so we're going to multiply both sides by volume first. We need to get that out of the denominator. And these will cancel, and we'll get volume times density equals mass. And then we'll divide both sides by density. And we'll get our equation. Volume equals mass divided by density. And we can see that the triangle method gave us the same thing there. And we're going to put the information in. So we'll have 25 grams divided by 0.87 grams per milliliter. Now what's going to happen to the units here is we'll have grams divided by grams, so that'll go away. And then we have 1 over a milliliter, which ends up just being a milliliter. So that gives us our units of volume, which is what we want. And use a calculator here. So we're going to have 25 divided by 0.87. And we're going to round that. We'll get 28.7 milliliters. All right. There's a couple more examples here that I want you guys to try, and then check back in the notes to see if you get them right. And just this one extra one here to try. Okay? All right, let's go on. So the SI unit for time is the second, so that's good. And the SI unit for temperature is Kelvin, but most scientists use Celsius. We don't typically use Fahrenheit, so that's something we'll have to get used to, because in our country we use Fahrenheit a lot in non-scientific work, but typically we use Celsius. So on a Celsius scale, water freezes at 0 degrees Celsius and water boils at 100 degrees Celsius. So you can see that's pretty easy to remember. So that's very advantageous. So the Celsius scale is divided into equal segments between those points, 100 equal segments between those points, to make it nice and simple. But the SI unit for temperature is actually the Kelvin, and there's a reason that we use Kelvin. 0K, or 0 Kelvin, is the coldest possible temperature known. What that means is there are no negative temps on the Kelvin scale, because there's no way to get colder than 0K. The conversion between Celsius and Kelvin is pretty easy because they're exactly 273 apart. So if we wanted to convert, Kelvin temperature can be found by adding 273 degrees to the Celsius. So we would just add 273. All right. You guys have some homework listed on the calendar, so go ahead and start that now.